Adding and subtracting radical expressions. Simplify each expression. Now, first, recall that when simplifying a single radical, we want to look for a perfect square factor of the radicand. The radicand is the number inside of the radical. We call the 12 the radicand. So we're trying to find a perfect square factor. In other words, a number that's a perfect square that is a factor of 12. So 4 would be an example of a perfect square factor of 12. 12 can be factored into 4 times 3. And the largest perfect square factor of 27 would be 9. And 9 times 3 is 27. The reason we want to look for a perfect square factor is because we can now split each of these radicals into a product of two radicals, like this. And we can find the square root of these perfect squares. The perfect square of 4 is 2, so we have 2 times the square root of 3, plus the square root of 9, which is 3, which gives us 3 times the square root of 3. Now we have 2 times the square root of 3 plus 3 times the square root of 3. If you have 2 of something plus 3 of something, that gives you 5 of that something. So as long as these radicals are the same, we can add the coefficients. But what's inside of the radical does not change. Just as if we had 2x plus 3x, we would get 5x. 2 times the square root of 3 plus 3 times the square root of 3 gives us 5 times the square root of 3. Pause the video and see if you can do problem number 2. Now, the perfect square factor of 8 is 4, so I will rewrite 8 as 4 times 2. And a perfect square factor of 45 would be 9. So I can break up the square root of 45 into the square root of 9 times 5. Now, we have 3 times the square root of 4 times the square root of 2, plus the square root of 9 times the square root of 5. The square root of 4 is 2, so we have 3 times 2 times the square root of 2, plus the square root of 9 is 3, so 3 times the square root of 5. Here we can multiply the 3 times the 2, which gives us 6, so we have 6 times the square root of 2, plus 3 times the square root of 5. Since these two radicands are not the same, we cannot combine these two terms, and all we can do is stop here. So 6 square root of 2 plus 3 square root of 5. Now pause the video and see if you can do problem number 3. So, 28 has a perfect square factor of 4. 4 times 7 is 28. So I'll rewrite this as 5 times 4, the square root of 4 times 7x minus 8 times the square root of 7x. Since 7 has no perfect square factor, I can't do anything to simplify this. Now I can rewrite this as 5 times the square root of 4 times the square root of 7x minus 8 times the square root of 7x. Square root of 4 is 2, so 5 times 2 times the square root of 7x minus 8 times the square root of 7x. 5 times 2 is 10, so 10 times the square root of 7x minus 8 times the square root of 7x. And since these two radicands are the same, I can combine these two terms. 10 of something minus 8 of something gives us 2 of something. So 2 times the square root of 7x. Now pause the video and try problem number 4. So, the largest perfect square factor of 125 is 25. So I will rewrite this as the square root of 25 times 5b plus 3 times, the largest perfect square factor of 20 is 4, so 4 times 5b plus the square root of the largest square factor of, or the largest perfect square factor of 45 is 9, so that gives us 9 times 5b. So we have the square root of 25 times the square root of 5b plus 3 times the square root of 4 times the square root of 5b plus the square root of 9 times the square root of 5b. Then we have 5 times the square root of 5b plus 3 times 2 times the square root of 5b plus 3 times the square root of 5b. Now in the next step, I'll just combine the 3 times 2, which gives us 6. So we have 6 times the square root of 5b, and we still have 3 times the square root of 5b, and 5 times the square root of 5b. And now, since all of these terms are alike, we can combine them. 5 plus 6 plus 3 is 11 plus 3, or 14. So 14 times 5 times the square root of b.